Hello and welcome. In this video we're going to be building a very interesting application from scratch. And then when we finish the application, what we're going to do is optimize the code so make it more maintainable in the future and to make it run much faster. Now if you like this video, please click on the like button below, and if you'd like to hear more about my upcoming videos, then click on the subscribe button. The full source code for this video is available from the description below. So let's go ahead and get started by looking at what our application is going to be. So this is our application, and what we want to do is we want to take what's in the input on the left hand side and we want to write it out as the output on the right hand side. But with one difference to what we would normally do. In the criteria, we want to specify how much of each we want to get back. So for example, if we just want to get back the first two banana sales, so what we do then is we put banana and max is 2. So we just want 2 items back. We click on run report and you can see that it just brought us back the top 2 banana items. Now if we add something else there, like let's say we add mango, and for example we put in 4 for mango and then we run the report. So as well as getting back the top 2 banana, we also get back the top 4 mango. So this is how we want our application to work. We specify in our criteria the max we want to get back for each fruit, and then when we run the report, we get this in our output. So now that we understand what we're trying to achieve, we can go ahead and write the code. Now this is quite an interesting one, so maybe you might want to try it for yourself first and see if you can figure out how we did it. But anyway, let's go ahead and let's start writing the code. Okay, so let's press Alt F11 and enter the Visual Basic editor. So the first thing we want to do is set up our button click. So we do right click and we do insert module. And what we do in here is we're going to have our click events. So our click events are quite simply when we click on a button and it basically runs a sub. So we call this module click event, so it's quite obvious. And then we'll have public sub run report, and we'll say underscore click. And then we'll just put in a message box here just so that we know that it worked. So let's Alt F11 back to the button. We right click on the button and we assign the macro. Click on it and click OK. So now when we click on run report, you can see that it brought up our message box. So we know that it's connected correctly to this run report click sub. So the next thing we want to do is get down to the actual code itself. So we do insert and then we do another module. And what we're going to call this one is we're just going to call it report. So we'll do mod report. Now we always put mod before the name of a module so that it doesn't conflict with the name of a sub or a function or a variable that you have. So in here we're going to have a public sub again, so public sub, and we're going to call this one main. So we'll just call it main. Now we can call it anything that we want. So if we go back to our click events, in here we just have call main. Now one thing I always point out, and it's very important, is that in our click events we don't put any code, because this would make things very messy indeed. So our click events are basically just going to call other subs and then let the subs worry about the code. So this makes it very easy. We can have just in our click events a list of different click events, and it will be very obvious what the click events are, whereas if it's full of code it gets very messy trying to figure out how many we have, trying to delete one, trying to add another one. So much easier just to have the click event, call another module or another sub and let that take care of everything. So now we're back in main. What we want to do in main is we want to do basically 3 things as we've seen from our example. So the 3 things we want to do is we want to read through the input, and based on the criteria we want to get back a certain amount of items, and then when we've got those items back, what we want to do is write them out. So the first thing we want to do is read the criteria, because we need the criteria first. The second thing we want to do is we want to read through the data with the criteria. So read through data using criteria. And the final thing we want to do is write out the results. So So as I normally do when we have these three things in place is let's create a sub for each one. So the first one we'll call obviously read criteria. The next one we'll call read data. And the final one we'll call write results. And now let's make these into subs. So we can just do, and I'm going to make these private, and the reason they're private is that they shouldn't be available outside of this module. Private sub again. And let's just get these ones in and remove the space. So let's do a debug compile, and this makes sure that everything is okay. And then we'll run the code. And again, just to make sure everything is okay, hit F5 and it runs as we expect. It doesn't do anything, but these just mean that as we're writing the code, it's still absolutely fine. Now, when we're reading through the criteria, what we want to store the criteria as is a dictionary. So the reason we use a dictionary is that the dictionary is a key pair value. So what that means is that we store something as the key and then we store something as the value. So this is similar to a real world dictionary where we store the word as the key, and then by going straight to that word we can get the value, which is the definition. So the reason we use the dictionary is that we can store the fruit, and then when we read through an item we can go to the dictionary and say, okay, how many items are left in banana to read? Now if we use an array, it's more tricky because each time we go to banana we have to read through all the items in the array to get to banana to see what the value is, whereas the dictionary allows us to access it directly. So therefore we're going to use a dictionary for the criteria. So we do dict as dictionary. Now the dictionary doesn't exist here, so what we do is we do tools, references, and we select scripting runtime. So it's Microsoft scripting runtime, which is way down here, and you can see it here. Now if you're using the Apple Mac, this isn't available, but what you can do is that if you Google in GitHub, there's a dictionary available and it works exactly the same way. You basically just take the code and drop it into your project and it works just as well. So what we're doing is we're creating the dictionary. Now we're not creating a new dictionary here. We're going to do that in read criteria, and then we set dictionary equal read criteria. So what this means is that we're going to create the dictionary in read criteria, we're going to fill it, and then we're going to pass it back to this variable, the dict variable, and this variable will then store our dictionary. So what we'll do then is we'll go down to our read criteria. We know this is returning a dictionary, so therefore it must be a function because a sub cannot return anything. So that's why you can see that we've got an error here. So let's make this a function, and what we do at the start of this function is we do dim diction and as new dictionary. So dim dict as new dictionary, and this creates the dictionary. And then at the very end what we're going to be doing is we're going to be returning the actual dictionary as well, and somewhere in between here we're going to fill it. So by doing this at the start, it makes it very obvious. It gives us our structure, makes it obvious what we're doing, and we don't have to think about it. Kind of simplifies what we're doing. We don't have to think about what are we doing with the dictionary, are we returning it, and so on. So let's do a debug compile. Everything is okay, and let's run the code, and I'm going to put a breakpoint here so that we know it actually runs. So we press F5 and it runs, and we press F5 again. So everything worked according to plan, and so now we'll work on the read criteria. So what we do with the read criteria is we want to read the data, so we do dim rg as range, and then we set the range equal to, and the range is F3, so it's sheetfruit.range F3. We say current region, which gives us back all the adjacent data. So if we have a block of data, it'll bring us back all that block of data. So this gives us our range, and once we have the range we run through it as follows. We say for I equals, so we're skipping the header, so we're starting at row 2 and we want to go all the way to the last row, which is rows count, and then we do a next I. And then what we're going to do is we're going to add the value. So let's do fruit equals range dot cells, and it's I, which is the current row, and it's in that range, it's the first column. And the second one then is column 2 and max. And we declare fruit as a string, and we declare max as a long. And now the one thing as well, so when we're adding to a dictionary, we could just add straight from the cells, but by doing it like this, it makes the code just that bit more readable, and it's very easy to see. We're adding a fruit, we're adding a max value to the dictionary. So now that we've done this, we'll do a debug compile, and then I'm going to put a breakpoint here, and I'm going to run the code from the spreadsheet. So I'm going to click on run report, and you see it stops there. So what we'll do at this point is we'll add the dictionary as a watch. So the dictionary is in the watch window. Let's open it up, and the dictionary has 2 items, and those items, the keys are banana and mango. So as far as we can see at this point, the dictionary appears to be correct, and we've successfully read in the items. Now we could do a simple sub that prints everything to the immediate window if we wanted to be sure, and we do this in a case where we were reading lots of items and it was difficult to know if we'd done it exactly or if it was correct. So now that we've read back the item correctly, the next thing we want to do is we want to read through the data. So let's have a look at the spreadsheet to see exactly what we're going to do. So what we're going to do first is, as we've just done, read the criteria, and then we're going to read through the input list. Now when we read each item, so say we read mango, we first of all check if it's in our criteria list, and if it's in our criteria list, what we do is we check if the max value is greater than 0. And if it is, we add this to our collection, which is how we want to store these rows. Then we move to the next item, and again it's mango. We check if it's in our list, and we check if it's got more than 0 items. So every time we find an item and we add it to a row, we deduct 1 from the max value. So let's do this just as an example so we can see exactly what we're trying to achieve. So imagine this is our dictionary in memory, and this is our key, and this is our max value. And what we do is we read mango first of all. Is it in our list? It is. Is mango greater than 0? Yes, it is. So we copy that to our collection, and then we take 1 off of mango. So now it has 3. So we go to the next item, and again it's mango. Is that in our list? It is. So we add it to a row because its max value is greater than 0, and then we deduct 1. And we keep doing this as we go through our row. Eventually mango will hit 0 when we get down to the 4th one, and then when we hit any mangoes after that, such as in A15, it won't read them because mango value is set to 0. And does this, of course, for all the fruit. So that's what we're trying to achieve in our code. So we're going to use a collection to store the data that we read in rows. And the reason we use a collection is that it's very simple to use, because the collection, all we have to do is add the range, the row range, to that collection. We don't have to insert or do anything that we would have to do with an array. So the collection is very useful for this, but later we'll be using the array because the array is much faster. So let's create the collection, and we just declare the collection here. We don't use new. This is a key point because we're not actually creating the collection here. We're just creating the variable, and then we're going to pass it back from read data to this variable. Now read data, we're going to pass it the dictionary, and we're going to use that criteria when we're reading. So because we're passing it, we put it in here as the parameter. And then what we're going to do in read data is we're going to create the collection. So dim call as new collection, and then we're going to pass the collection back at some point. So we do set read data equals collection, and this means we're passing it back. And then here we're going to read the data. So if we're reading the data, we can pretty much take most of this code up here. In fact, let's take it all, and then we can just edit it because it's pretty similar to what we're going to do. This one is going to be A3, and what we want to do then is we want to read the fruit. So the fruit is going to be the first value, and then what we want to do is we want to check the fruit in our dictionary. So we say if dictionary exists. So does the fruit exist in our dictionary? So if it exists equals true, then what we want to do is we want to check if that fruit is greater than 0. So if the max value is greater than 0, then we want to do something. And what we want to do is actually, we want to add the row. So we want to do call.add, and we just say the current row. And the current row is very easy to get. It's range.rows I, which gives us back the current row. And we do endif for the first one and endif for the second. Now, the other thing that we want to do is we now want to deduct one value from the fruit. So say the first fruit was mango, we do dictionary fruit, and that equals itself minus 1. So that equals what the current value is minus 1. And this should bring us back all the data that we expect. So what we're going to do now is write out the results, and this is something a lot of people find tricky because of the way we have to track the rows as we write stuff out. So we're going to be passing the collection, but what I like to do is I like to call the actual sub that we're using, and if we use call or we use anything before a sub, then the parameter must go in parentheses like this. Now call is optional, but you can see it makes the code a little bit clearer. So the first thing we want to do in our write result is we want to add our parameter here, and then what we want to do is we want to clear any existing data that's in the cells. So any previous runs of our code that wrote out data, we want to make sure that they're clear. So we do range, we do J3, and this gives us the range, and we do current region, that will give us all the data. And one thing is we don't want to delete our header, so what we do is we just push down one row, and then we do clear contents. And of course we do a debug compile as normal, and then what we'll do is we'll actually test this out by just putting some bits of text here. We click on run report, and you can see that it emptied the text, so it worked fine. So what we do next then is we do dim item as variant, and we say for each item in the collection, and then we end with next collection. And we want to write out what's in item, so item.value, we want to write that out somehow, and we're going to write it out in sheet fruit and cells. We're not sure of the row yet, we know that it's going to be value. So you can see I'm just filling in all the things that we know that we don't have to really think about at the moment. And it's going to be in column 10. Now we're changing these numbers because we don't like to have random numbers in our code. We're changing these numbers later as we optimize the code a bit. And so it's going to be column 10, and it's going to be row. So what is row? We'll set the row, dim row as long, and row will equal to 4. So let me just look at our output here. So our row equals 4. You can see it's just under fruit in column J, and column J of course is 10. So that's where we're going to start writing our output. Now every time we write out a row, we need to move to the next row. So we say row equals row plus 1. And this gives us the next row. Now again, let's do a debug compile. That should be next item. We do a debug compile again, and everything seems to be fine. We'll now run the code and see what we get. And you see that we get all the fruit, but we don't get the amounts at the moment. So the reason we don't get the amounts is that we have to resize. Whenever we assign a value to a cell like we've done here, we have to resize this. So the cells has to be the same size as the row that we're outputting. Whereas if we do a copy and paste, Excel automatically knows to paste whatever we've copied. So it'll paste the entire row. But when we're assigning, we have to set the size ourselves. So we do this using resize. Now the row size is obviously going to be 1 because we're pasting a row. And the column size is going to be item, which is, remember, our row. And it's the number of columns in our item. So columns.count. So if we do, of course we should do a debug compile as usual. And then we go back here, we click on run report, and you can see that it filled in all the data as we were expecting. In a normal application, when we do this, of course, we check all this data and make sure that our output is correct. And so let's run it with grape and just see what we get. And we'll even just change the value for mango just to see. And then we run it and you can see it gave us the right results. You can even add banana here. And let's say we want 3 items this time. We run the report and you can see it gave us back everything that we were expecting. So now that we've written this code and it's working as we expect it to work, let's go ahead and optimize this code and see how we can make it just that much better. So if we go into our constants here, this is a module that I've created. So the purpose of this module is basically that we just want to have all our constants in one place. So we use enums to put them there. And the second reason it's useful is that if we read the code, rather than seeing numbers like 4 or 6 or 10, we can actually see text, and that makes our code much easier to read. But the real beauty of this is that in the future, if we change our range and move it somewhere else in the Excel spreadsheet, we just change the values here and everything should update as long as we've written our code correctly. So if you're not clear on enums, an enum is kind of similar to what we use. Say we're pasting something, we use a copy and paste, and we want to paste the formats. So we use Excel paste like this. And you can see all the different options. We've got paste all, we've got paste comments, format, etc. And so we store related constants together like this. And then when we want to use them, it just makes the code much easier. And if we actually pass them in as parameters as well, VBA can use them in the IntelliSense. So let's update our code with these. And where we have J3, instead of having J3, what we do is we have cells. And we want to put in the row and the column. So that's going to start with, it's going to be our output header is 3, and it's going to be our output column header, which is 10. So you can see header, and this one is AR row output, and we've got output start or output header. So we're going with output header here, and this one, the row, this is AR output row. So it's going to be the output start. And you can see again, we've got the column here and we replace the 10. Now, generally in the code, we don't need to worry about replacing values like 1 or 0. So row equals row plus 1. There's no point in changing the 1 here, as it's pretty obvious what we're going to do. But for things like columns and all, if in the future we change anything, then we just change the value in our constant module and everything will update. As long as we've written the code right, it'll make a difference. Now, if you're writing a small project, you might notice this, or you might think it's too much effort to do. But when you have a large project, it's vital to have this in place. So I'm going to go ahead and update all the code with these changes. So now I've updated everything here. You can see that the code now doesn't have any kind of magic numbers hanging around. And this makes our code, as I said, much more maintainable in the future. So what we're going to do now is optimize the code, and we're optimizing it for speed. So what we want to do is we want to get rid of all the times that we talk between VBA and the range. So we want to cut these down to as few as possible. So how we do it is we basically copy the range to an array, and then we use the array because the array is in memory, it's much quicker. And then at the end, we write it back in one go. So rather than writing it back in multiple goes like we're doing at the moment, we just put it all back in one go. So let's see how we do that. So the first thing we want to do is want to change read criteria to a array. So as variant. So variant means basically that VBA will set what it is at runtime. And normally we avoid using variant, but in this case, we have to use variant to allow VBA to create the array from the range. And we just say array equals the same as before. And instead of just current region, then we just put value at the end. So current region, the first part of this will give us back a range, and we're just saying give us the value. So give us all the data. And how we go through it then is we use L bound. So L bound, and we do array 1 to U bound array 1. So that's from the first row in the array to the last row in the array. So the 1 refers to rows. If we had L bound 2, it refers to columns, or what we'd say the second dimension. And then of course we don't need range cells, we just use array here. We don't need range cells, we just use array here. And we get rid of the value. And what we do then is we do a debug compile as normal. Everything seems fine. And what we want to do is we want to run the code and make sure it ran okay. So let's clear our data here. Let's run the report. We got an error. The error is that it's a type mismatch. A lot of the time when you get a type mismatch error, the problem is, let me run it again so we can see. Type mismatch means that we've put the wrong value in a variable it's not compatible with. So in very simple terms, what we've done here is we've put text into a long integer, and obviously that doesn't make sense. And the reason is because we started at the header. So L bound should actually be L bound plus 1. So we start not the first item in the array, which is the header, but the one after it. So let's stop this code, debug compile, even though I've only made a small change, and let's run our report again. And you can see that it ran perfect. And it should be running quicker, but we'll be testing that a bit later. Now the second thing that we want to do is we want to, out here, we want to actually not use a collection anymore. We want to use an array. Now the thing about the array is, if we don't know in advance the size of the array, we have to keep resizing. And it's a bit messy and can slow us down a bit. But in this case, we actually know in advance, because if we sum all the max values, we actually know how many output records we have. So we can build our array in accordance to this. So we have an array called result, and we set the size. So we can set the size here. We know that it's not going to change. And the size that we set it to is going to be 1, 2, and we'll get back to that in a second, and 1 to 2, because 2 is the number of rows. Now we should make 2 as well. We can do that later. We add that as an enum so that the number 2 isn't just appearing here. And what we want to do here is we want to have some value that tells us what the number of criteria is. So what the total value is coming back. And when we're reading through criteria, that's when we should get this. So we're reading through criteria here, and we should be able to sum at some point here. We can say equals something plus. So let's just call it x for the moment. So x equals x plus max. And at the very end then we'll have the total value. So the problem is that we're trying to pass back 2 items here. We're trying to pass back the dictionary, and we're also trying to pass back the number of items. So 2 different things. So one way we can do it is we can pass them by ref, and then when they're changed inside, they're changed outside. But that's not really a nice thing to do because it's quite subtle and it's not obvious in the code what's been changed. So a much better thing to do is to pass it back, and we just create a simple class. So insert class module, and we'll call our class criteria. Now our class has 2 elements, and the first one is a new dictionary, which we'll create here, and the second one is the total. So it's the total criteria that's going to store that, and we say as long. So you can see this is the class here in this case. It's just a very nice way of storing related variables together. And so how this works then is actually not so complicated. So we're going to be not passing back a dictionary. In fact, we're going to be passing back the criteria object. So as CLS criteria, and we make this O criteria. So this should be passing back criteria as well. And we create the criteria here. And of course it's new, so we're creating it here. And then we use the dictionary. So instead, anywhere we have dictionary, we just say the criteria dictionary, like this. And we've only have it actually in one place. And then we say the criteria total equals itself plus, let me just criteria, so criteria again equals the total plus the max. So we read the max, we add it to our total, and at the end we'll have the total of all the values. And then we pass it back. And then when we get back here, what we're basically doing is instead of the dictionary, we're passing the dictionary of the O criteria. And here then, our total is going to be O criteria. and it's going to be total. And we do a debug compile, everything seems fine, but what we want to do is we want to just put a breakpoint here and just make sure that the values are correct. So let's run the code to here. Our criteria total is 6, and that is actually the correct value. So what we'll do is we'll stop the code and let's run it again. But this time we're going to just change it up a bit so that we can see some more stuff. So let's put in banana, let's put in say 3 for banana, let's put in orange, and now we have 9. So when we run our code again and we look at total, so let's add it to the watch window and let's bring the watch window up here. We can see that our total is 9. So you can see here that the total is 9. So very nice way of passing back the stuff, and it keeps our code nice and neat. So we've got our array, and what we're going to do with our array then is we're going to fill the array instead of filling the collection. So we don't need the collection anymore. We're going to get rid of this, and what we're going to do is we're going to be passing back the array back like this, but we're also passing it in. Now we don't have to pass it back, because once we pass it in it's going to be updated anyway. But the reason we pass it back is that it's very clear in the code that we're passing back the array. And then of course down here we're going to be passing it in. So if we go to write result, we have to change our parameters. So we just do result as, and that's a variant. And we just the same thing again in our read data. We just have result as a variant. And in our write result, we're going to comment out everything. We'll get to this a bit later. We just want to get the first part of our code working correctly. So we do a debug compile. So write result, actually we're not using the collection anymore, so we remove the collection. We do debug compile and everything seems to be okay. So we have to go to read data now before we do anything else, and we want to update it. So there's no set here. We're saying read data equals result. And now instead of range, we're going to use array variant, which is an array. And the array equals this dot value, and then we use the same thing up here. We use L bound to read through it. So L bound to U bound. And of course, anywhere that's RG cells here, we can just change this. Actually, it's only one here. So we can just change this to be the array. What we want to do then at this point is we want to add the row. So let's get rid of the value up here. And we're saying dictionary equals dictionary minus 1. So we want to just continue doing that as normal. So how we add the row is like this. We need to create an add row sub. And so let's have our sub, and it's going to be add array row. And we're going to do result as variant. So this is the result array. We're going to have the result row as long. We're going to have the array as the variant. And we're going to have the row as long. And that will pass back the array. So that should be a function. So we'll make it private here. And what this simply does is it copies the current row that we're looking at in the main array, and it copies that to the result row. And how we do it is quite simple. It's just simply a for loop. So even though it's a for loop, it's actually still very quick because it's in memory. And L bound, so this is 2 because we're reading through the column. So it's L bound to U bound array 2. So we're just reading across the columns. And I use J here because we normally use I for rows and J for columns. So then we say the result array, so result, and that's at result row, and it's the current column, equals the main array, and that's at row, and that's at the current column. So we do a debug compile. So read data equals, so this should be variant, and debug compile again, everything is good. And what we do then at this point is we call add array row. So add array row. And what we're passing in here is the result. And we're going to pass in the main array, which is this one, and the row, which is I in the current one. And then we need the row for the result. So the row for result, we're going to say is just a row variable, and we'll set that row at here. So we set the row as long, and the row equals 1. So the first time we're going to place it in position 1 of the array. And after we add it, what we want to do is we want to move row onto the next position. So row equals row plus 1. So if we do a debug compile, everything seems fine. So let's run the code and make sure that it runs okay. So we'll run the code from here, and we'll put in a breakpoint so that we can check what our results look like. We run the code, and now we'll add result to the watch window. So we can do click on that and press Shift F9, and then just hit add, just hit enter. And then we open the result, and you can see we've got 9 different items. And then let's have a look. So we've got mango 2701, mango 4356. So everything seems to be good. Okay, so now that we've got that working, all we've got to do now is we want to write out the results. So how do we write out the results? So we go back here, let's just put this code back in. Now we don't want this code, we actually don't need any of this code here. We can just get rid of it. And how we write it out is as follows. We're going to be writing out the entire array that we got, and we just say equals like this. That's all that we've got to do. We're going to have some kind of range that it's writing to, and that's going to be on sheet fruit, and it's going to be cells, obviously. That's our starting point, and it's going to be AR output, and that's the start row, so we don't want to start in the header row. And of course the column is the same, it's the header column, so the starting column for the header, and we want to put that out. So we want to do value like this. Now this won't give us the entire result, but we'll come back to it in a second. Again, we do a debug compile. So let's go to our worksheet, and let's run the report, and you can see that it just wrote out mango. So the reason that it just wrote out mango is because we have to resize the range we're writing it out to. So if we do a copy and paste in VBA, what happens is when we paste it to a cell, the results are bigger than the cell, then Excel knows that it's bigger and it just pastes out everything. But when we're assigning like this, we have to specify the exact range that we're writing it to. So what we do here is we just do a resize, and the resize is going to be rows and columns, which we're going to calculate in a second. And so rows equal, so basically L bound, so L bound result, so it's going to be the rows of the result, so we use 1, and columns is going to be, that should be U, and columns is going to be 2. So columns, when we use U bound 2, it's the columns. So it's the columns, and obviously we want to declare these variables, and columns as long. So let's do a debug compile. Everything seems good. Let's do Alt F11 and let's run this code, and you can see we got the results that we were expecting. Let's try a very simple one just to see that it worked correctly. We'll run it again. So we just have one grape. Let's try, say, banana 3, and you can see that it did everything okay. What we've just done is optimized our code to make it run a lot faster. Now, it's one thing to say that we've optimized the code and it's better, but has it actually made it faster? So let's check the results by running the original version and the optimized version and see what the results look like. And of course, we're going to add a lot more data when we do this. So to test the speed of the optimized code and the non-optimized code, we use this micro timer. Now the micro timer is available. If you just Google VBA micro timer, you'll see it's on Charles Williams' website. And what this allows us to do is it allows us to time to 1,000th of a second. And that means we need a lot less data to run our test with. Whereas if it was a second, we obviously need much more data. what we're going to do is we're going to run the code and we're going to run it against a spreadsheet, and in the spreadsheet we've got a lot more data. So let's look at the spreadsheet here. You can see that our input is 6,000, our criteria is 4,500, and our output should be 4,500 as well. So let's clear the output just to show that it works. And when we run the code, in the immediate window on the right hand side, we're going to write out the result of how long it took. So let's run it the non-optimized way. And you can see it took 447 milliseconds. So let's run it again. It's good to run it a couple of times just to get an indication of how long it's taking. And you can see it's taken about 440 milliseconds to run. So let's run the optimized version. And you can see the optimized version is about 10 times faster. Now, one thing is I'm turning off Excel settings in both of them because I just want to compare it using the array and not using the array. And if we leave on the Excel settings, then they'll make it actually the original one a lot slower. So I'm just using them for both of them. So let's run it again. We get 45. So the key here is that the big difference we get in speed is because we're not continuously going back to the spreadsheet. We only go to the spreadsheet to read the criteria data. We do that once, we put it in an array. We do the same thing for the input data, read it once, put it in an array, and then at the end we write it all out from an array straight to the worksheet. So we've only got 3 trips to the spreadsheet. And you can see that it makes the code 10 times faster. So this completes the application, and we've designed this application from scratch to solve, which is a tricky little problem, and then we optimize it to make it run super fast. So in certain cases you don't need to optimize it. I mean, if you just have a small bit of data, it's not always necessary to optimize, but if you're dealing with a lot of data, it's important to know how to do it. So I hope you enjoyed this video, and if you did, please click on the like button below. If you'd like to hear more about my upcoming videos, click on the subscribe button, and you can hit the bell icon below, and that'll notify you when my new videos are released. Now, if you like the optimization here, you should check out my video, how to make your code run 1,000 times faster, where I cover this and all other optimization techniques. So if you have any questions, queries and comments, please leave them in the comment section below, and I hope to see you on the next video.